In this presentation, we will be dealing with the science of fluid motion. As we proceed from a particle to a rigid body and then to motion of a fluid, the science becomes extremely complex. In our earlier presentation, you have seen, we have shown the motion of a rocket, even in a helicopter. But when you look at this plane, the aeroplane, which also is dependent on the motion of airflow over its wings and the body, we find the science has become highly complex. I remember as a student, textbooks and other scientific books gave a very short answer that the aeroplane flies on the principles of Bernoulli's, and that stated because the motion of the air was faster on the top of the surface of the wing than at the bottom, there was a pressure difference causing a lift. But none of the books explained why was the motion faster on the top of the surface of the wing. Few years back, I attended a program in IIT Madras where one professor, Dr. Manu Jaiswal, gave a presentation which discussed how aeroplanes fly. I was astonished to learn that while Wright brothers discovered or invented the plane in 1905, it took nearly half a century or even more to understand how an aeroplane flies, how the air movement over the wings causes the lift. And even it was told that the famous scientist Albert Einstein knew little about how aeroplanes fly. Now in my presentation here, I'll be presenting two simple experiments. And in these experiments, I'll be demonstrating the complexity of fluid motion, which apparently looks at the first look as contradictory. In this experiment, I'm using an ordinary funnel, the funnel which you use for pouring fluid in a bottle or a jar. I have attached a balloon at the pipe end of the funnel, and I have a ping pong ball with me. If I put the ping pong ball inside the funnel and leave, the ball is bound to fall down because of gravity. But a very surprising thing happens when I fill air into this balloon and put the ping pong ball inside and see what happens. Here I have the inflated balloon. Now I gently put the ball inside and release the air. To utter surprise, while the air is flowing from the balloon outside, the ball doesn't fall down. Some books try to explain it by saying there was a high pressure below and low pressure above which was keeping the ball up. But if there is a high pressure below and low pressure above, how will the air flow? The air has to flow from high pressure above to low pressure below. You saw in this presentation how air flowing out of this blower held this light ball at an angle, and the air, after blowing the ball up to a distance, held it like a rope or a pole, and it moved along the air as I moved the blower. This is a very baffling phenomenon. It explains the effect of air flowing over a surface of a rigid body, and it behaves differently with different shapes. This has been explained by two famous effects called Coanda effect and Magnus effect. But they are highly complex, but they go on to explain the very important phenomena how aeroplanes fly.